Okay. So for this chapter, at each chapter, I will tell you what are the learning outcomes. This is the learning outcomes. After completing this chapter, you must be able to state the physical quantities and their respective SI units, sketch vector diagrams, resolve vectors into their respective components. So these are your aims, the aims that you want to, the things that you want to learn in this chapter. And possible questions in the exam. So this is where the learning outcome becomes useful. So perform vector additions and then perform vector multiplications. Okay, so these are the things that we are going to focus on. Okay, so base quantities, very straightforward. Base quantities is length, mass, time, temperature, something that is not derived. Okay, because we have another quantity called derived quantities. Length is just made out of length, but for derived quantities, for example, speed, it is made out of distance over time. So you have one base quantity here and another base quantity here. So because you have because you have more than one base quantity for speed, it is a derived quantity. So that is how you differentiate between base quantity and derived quantity. And another example would be density. Density, you are familiar with this one. It's kilogram over meter cube. Kilogram is mass, meter cube is volume or length times length times length. So mass is a base quantity, volume is a base quantity. So you have two things over here. Sorry, volume is not a base quantity, but length is. Mass is a base quantity and length is a base quantity. Volume is a derived quantity. So you have a bunch of base quantities inside density formula. So this guy is a derived quantity. Okay, so that is how you differentiate between base and derived. You have to memorize what are base quantities. For example, length, mass, time, temperature, electric current, amount of substance, luminosity of light. You have to know what are the base quantities. Derived quantities, we will learn as we go along. Tapi base quantities ni kena ingat lah. Okay, the question can ask you, list down 5 base quantities and their units. So that is something that you need to memorize. Okay, or you just have to know. Some people don't have to memorize. Okay, so why is units and system of units very important? Because it is to communicate the magnitude for a quantity. Defining unit allows everyone to relate to the same fundamental amount. Okay, for example, Radin says, why am I writing Radin's name? I want to draw a stick figure. So this is Radin. Sorry, Radin. So Radin said, okay, my arm is the length of 3 carats. So he's saying that his arm is 3 carats, right? And then this is Radin. And then Vikram comes and he tells me, doctor, my feet is the length of, okay, this is Vikram. I have to draw. So this is Vikram, sorry, very poor drawing. So Vikram said, okay, look at my foot, doctor. My foot is the size of 1 asparagus. And I'm like, what on earth are you guys talking about? So when we have like different units, when we define a length in different units, we can't relate to each other. So this is why SI units is very, very important. So I said, Radin, I don't want to hear about your carrots. Please tell me your length, your arm length in meters or like in centimeters. And I tell Vikram, I don't want to know about your foot. How long is the asparagus? Yada, yada. Tell me your foot size in meter or centimeter. Okay, so this is where SI unit is very important. It allows us to relate with one another. Okay, so imagine if I'm defining my laptop size by the size of carrots. Carrots have different sizes, so that's gonna cause chaos in the world. So we don't want that. Okay, so this is why SI units is important. Okay. Okay, so base quantities and its base units. So we have length, we have feet, inch, and meter. This guy is the SI unit. When we are solving problems, please use the SI units. Don't follow the US using feet and inch. They can use that on their own. Please stick to the SI unit. It will make everyone happy. Okay, and then we have mass. This is the SI unit. It is in kg. We also have pounds. It is denoted as LB, pounds. Okay. And again, that is a US punya standard unit. We are going to use SI. This is SI. And then we have time, which is in seconds, and we have hour. Hour is not an SI unit, it's the derived quantity, I think. But basically time is in seconds lah. That's the base unit. And then temperature, we use Celsius. And other forms of temperature can be Fahrenheit or Kelvin. Kelvin, we will use this in gas. Gas punya equations, which will be coming up soon. Or is it next semester? I think it's next semester. Okay, so we will use Celsius or Kelvin. Fahrenheit ni tak pakai, it's US units. Okay, and then we have our derived quantities. Speed can be in miles per hour. This is M, not for meter, it's miles per hour, or kilometer per hour, kmph, or meter per second. We like this one. This is the SI unit, right? Meter is SI unit, second is SI unit. And then we have area, square feet, okay, square feet, that, or square inches. This is supposed to be square, and then square meter, or like this, okay? So do you guys have to memorize? Yes, I would say so. You have to know that length is in meter, mass is in kg, time is in second, temperature is either Celsius or Kelvin, and then speed, it's length over time, so it's meter over meter per second. Okay, just basic stuff. Okay, so the SI unit, they define the SI units not like randomly. They have like a certain way of deciding it. So for example, length, the SI unit is meter. Meter is defined as the length of the path traveled by light in 1 over 299,792,458 seconds. Do I care what this means? No, not really. Let's just focus on length is meter. But I'm just telling you here that they did not come up with meter randomly. There is a basis to everything. So let's just focus on this side, okay? Okay, all right. So time, they said, okay, let's define second as time required for 9192631770 periods of radiation emitted by cesium atoms. Do I care about it? No. Okay, let's just remember the second. And then mass, kilogram. Platinum cylinder, I think this is in your textbook SPM code. Platinum cylinder in International Bureau of Weights and Measures, Paris, blah, blah, blah. That was how they define kilogram. Okay, moving on. So just to recap, we've learned about length, which is in meters, mass in kilogram, time in second. Oh, I've not mentioned about electric current yet. It is in ampere. Do you have to memorize? Yes. Temperature is in Celsius or Kelvin. Amount of substance is in mole, which is what I said yesterday. Was it this class? Do we have a Molly in this class? Is Molly in this class or the other class?
No.
Not in this class. Okay. Sorry. Okay, so amount of substance, the SI unit is mole. And then luminosity of light is candela, or the unit is CD, capital C with a D. Okay. And then this is derived quantities, area. Area is length times length. So you have meter and meter. So you get 2 meters. So meter square. Density, mass over volume, kg. Volume is meter times meter times meter because it's length times length times length. So you get kilogram over meter cube. Or you can also write it like this, kilogram meter to the power of -3. It's the same thing, okay? When you have the division sign, it is positive. When you don't have it, when you don't have that thing over here, that division sign, it should be negative minus, sorry, it should be -3. Okay, so something, maybe some people dah terlupa, so I'm just like recapping this for you. Okay, force is in Newton. Force is in Newton, but we know that F equals to ma. So it is the derived quantity, right? So mass is in kg, acceleration is meter per second squared. So kilogram meter per second squared is force, but the SI unit is Newton. Okay, so they define Newton as kilogram times meter over second squared. And then we have pressure. Pressure is force over area. Force is in Newton, area is in meter squared. Oh, this is too small. What is it? N meter squared. Okay, so Newton over meter squared, you can write it like this, or the actual SI unit is called Pascal or PA. Okay, kena ingat. And then work is force times distance, F times S. We will learn this in coming chapters. Force times S. Force is Newton, distance is meter. So Newton meter, but the SI unit is in joule. So derived quantity ni agak pelik sikit, but that's okay. It's something that is useful later on. So again, you can write it like this. You can. But if they require you to write it in the SI unit, you have to remember it's Newton, Pascal, and Joule. But this is not wrong. It's not wrong. Okay? It's just another way of writing it. It means the same thing. Okay, any questions so far about base quantities and derived quantities? I hope I'm not going too fast. Lagi pun benda senang je kan?
No.
Questions? Okay, moving on. So we come to the next one, which is scientific notation. It is the style of writing long numbers precisely. Okay, so you have like a bunch of numbers that I mentioned earlier, macam ni. Like who has time to remember this, right? So we use scientific notation. I want to have two, what do you call it? Two decimal points. Two decimal points? Yes, I want two decimal points. So this would be 9.19 times 10 to the something. I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9. Okay, so this makes my life easier. I don't have to like remember a bunch of numbers. I just have to remember these three numbers. 9.19 times 10 to the 9. So this is called scientific notation. Okay. Okay, so it is written in the form of powers of 10. These are a bunch of examples. I don't think it's important to go over this. I think you know what scientific notation is. Okay, moving on. Oops. Saya punya laptop macam bunyi sikit because I don't know. I think because of Zoom. Okay, so scientific notation. We have addition. I don't like this color. Kejap. What color do I want to use? I want to use orange. So we have addition of scientific notation numbers. We have multiplication and we have division. And there's a certain technique to doing that. For example, addition. I want to add 3.1 times 10 to the 2 plus 1.2 times 10 to the 4. So how do I do that? I have to make these guys the same. So it doesn't matter, I can choose 10 to the 4 or I can choose 10 to the 2. But this example says, okay, let's choose 10 to the 2, which means that they have to convert this guy to have 10 to the 2. So if I'm converting this to 10 to the 2, so times 10 to the 2 times 10 to the 2, 1.2. I want to get rid of this guy, so I have to multiply over here. 10 to the 2 is basically 100. So 1.2 times 100 is 100. Why is this 1,200? This is wrong. Kejap. Betul kan salah ni? 1.2, betul lah. Okay. So kat sini dia terlebih kosong. 1.2 times 10 to the 2. Yeah. Okay, so it's 120 times 10 to the 2. So this example is wrong. Okay. So I hope everyone knows how I got the 120. Basically, I took out 10 to the 2, multiplied it over here. So I got 120. So I'm left with 10 to the 2. So now I have 10 to the 2, 10 to the power of 2 on both numbers. So now I can add them. 3.1 plus 120. So this is, what is it? 123.1 times 10 to the 2. Okay, so that is how you do addition. You make the guy over here the same. Either you choose the smaller one or you choose the bigger one. Doesn't matter. Okay, and then we have multiplication. Multiplication is much easier. So 3 times 12, 10 to the 2 times 10 to the minus 6. It's quite straightforward. 3 times 12 is 36. 10 to the power of 2 times 10 to the minus of 6 gives you this guy. Okay, so multiplication basically penambahan of these two. 2 plus minus 6 is minus 4. Okay, I think this is pretty straightforward. If you are struggling with this, I hope you are doing the revision on your own. I'm just going through this quickly. And then division, kalau kita punya to the power of ni, for multiplication kita tambah, for division we subtract. So 10 to the 2 subtract is subtracted from, sorry, 10 to the minus 6 is subtracted from 10 to the 2. So 2 minus minus 6 gives you 10 to the 8. And 16 divided by 0.5 is 32. Okay. I hope I'm not confusing anyone. Oopsie. 1, 2, 3. Okay, multiplication, these two guys, tambah. Division, these two guys, minus. Nombor yang ni tambah dengan tolak. But these two guys kena bahagi macam biasa. Bahagi macam biasa. Okay. And this guy darab macam biasa. Darab. Okay. Only 10 to the power of something for multiplication is tambah. It's addition. And for division, it's subtraction. Okay. So something for you to remember balik. I know that you guys have learned this. Okay, so now this is another example. It's 1,200 meter. It wants to convert to scientific notation. So I can do this 1, 2, 3. So I should get 10 to the 3, 1.2. It's like that. And then for this guy, 1, 2, 3, 4, 5. So I should be it should be 10 to the minus 5 because I'm going to the right. I'm going to the right. And this guy is going to the left. Okay. So this guy is minus 5. This guy was a positive. Ada perbezaan kat sini ya. So it's a 6 times 10 to the minus 5. So if I wanted to convert back this scientific notation, I can. So 6 times 10 to the minus 5. So 6.0 times 10 to the minus 5. I start with this point. I go backwards by 5. 5 times. 1, 2, 3, 4, 5. So 0, 1, sorry, 0, 0, 0, 0, 0. So 0 0.00006. I have 4 zeros, 6. Sama juga kat sini, 1.2 times 10 to the 3. I want to convert it back to its general number, I would say. So 1, 2, 3. So I get 1,200. Okay. Straightforward stuff. If you still struggle with this, please revise. Okay, and then abbreviation. Sometimes you don't want to put in these numbers. You can write it as giga. You can write it as mega. Okay. So for example, this guy was 1.2 times 10 to the 3 times 10 to the 3 times 10 to the 3 is equal to kilo. So this guy is times 10 to the 3. So I can rewrite this 1.2 K. I can. And then I use the units over here. It's meter. So 1.2 kilometer. Okay. And this guy dia nak tukar jadi micro. I don't know why. Menyusahkan diri. But it's okay. Let's try it. So 6 times 10 to the minus 5 grams. he wants to convert it to micro. So micro is 10 times 10 times to the, sorry, 10 to the power of minus 6, right? So we are missing another minus 1. So what should I do? I add a 0 over here times 10. So macam mana saya nak tunjuk ni? Sekejap. Let me write it properly. So I am missing 10 to the minus 1, right? So 6 times 10 to the 5 times 10 to the minus 1, but I can't just add it like that. So what should I do? Times 10 to the positive 1. So 10 times 10 to the minus 1, 10 times 10 to the power of 1. They cancel out. So basically it's just 6 times 10 to the minus 5, right? Okay, so, but I want this guy to be like together, right? I want them to be a couple. So 6 times 10 to the power of 1 is 60 times 10 to the minus 5 times 10 to the minus 1. So this gives me 60 times 10 to the minus 6, which gets us our micro, and I add the unit gram. So I get 60 microgram. Menyusahkan diri kan, but sometimes they want this from you. So you have to know it, okay? Okay, so example. Physics problem usually require the physical quantities. Use SI units consistently in calculations. Yes, we know this. This is to ensure the final value is valid, which is referring to the quantity in question. Okay. So example 1.1, the fastest speed on land is 330 kilometer per hour. This is not SI unit. Wrong. So we want to convert this to SI unit. What is the speed in meter per second? Okay, so let's do that. So kilometer, kilo is 10 to the 3. So I know that it is 1,330. Why is it? Sabar je lah, example salah-salah ni. Okay, so 330 times times 1,000 meter. 1,000 datang dari mana? Datang daripada kilo. Okay. And then 1 hour is basically 60 minutes times 60 seconds. Okay. So it's 1 times 60 times 60 seconds. So doing this, all the math, you get this answer. I hope it's the right answer. I'm not going to go do it. Tapi, I don't actually like this method. My preferred method is 330 kilometer over 1 hour. I want to convert this this quantity into meter per second, right? Okay, so I want to get rid of the kilo. I want to maintain the meter. So what should I do? So 1,000, sorry. I want to get rid of kilo, right? So 1 kilo is equal to 1,000. Okay, 1 kilo is equal to 1,000 times. I want to get rid of hour down here. So I should cancel it up here. 1 hour. 1 hour is equal to 60 minutes. Okay, baru minutes, and then I want to get rid of minutes. I don't want this in minutes. I want it in seconds. So times, I want to get rid of minute. 1 minute is equal to 60 seconds. Okay, it's the same, but when you do it this way, you will tend to not make mistakes. Sebab kadang-kadang saya selalu perasan ada orang buat 3 kali 60 lah, 2 kali 60 lah. So when you do it like this, it's much more organized. But if you feel more comfortable doing this way, by all means, please do it. Okay, I'm just giving you another approach to do it. So 330 kilometer per hour, I want to get rid of, let me use a different color. I want to get rid of kilo. I don't want to get rid of the meter. I just want to get rid of the kilo. So 1 kilo is equal to 1,000 or 10 to the 3. So K cancels out with K. And then I want to get rid of hour. 1 hour cancels out with hour. And then minute is cancelled out with minute. So now I'm left with 330 times 1,000 divided by 60, divided by 60. And use your calculator and you will get the answer. Okay? Tak ada cara yang salah. As long as you get the right answer, it's fine. Okay? So this is just another approach. Approach number 1. Approach number 2. Okay, moving on. Any questions so far? Everyone okay?
Okay.
Okay, remember you can interrupt me when
Okay.
okay.
Okay,
That's
okay.
good to know. Okay, next example. What time is it? Okay, let's take a break in 10 minutes. So please bear with me. Another 10 minutes and then we will take our break. So a cylinder of radius 50 centimeter is filled with water. So basically a cylinder. Okay. Wow, that's a beautiful cylinder. Okay, so cylinder of radius 50, 50 radius. So from the center to the end, 50 centimeter is filled with water to a height of 2.5 meter. How many liters is the water in the cylinder? Okay, so now it's asking liters, and liters is volume. But they did not give us any volume. But they've given us the radius and the height. Radius and the height. Okay, so for a cylinder, how do we calculate the volume? We calculate it by multiplying the circle with the height. So this is how you get the volume of a cylinder. So volume is base area times height. So your base area is a circle. This is the formula for a circle and the height. Okay, times height. Area of circle times height. And then you don't know what the area of the circle is. And they've given you the radius, which is 50 centimeter. So you have to convert that to meter. So 50 centimeter convert to meter is divided by 100. So 1, 2, 0.5 meter. Betul tak? Time, betul. 1, 2. Okay, 0.5. Tapi kat sini dia orang calculate everything in centimeter, which works as well. Okay, so I want to do it in meter. Suka hati lah kan? So base area, let's find the volume in meter. So area of circle, sorry yang tulisan buruk. Dah lama tak menulis, pakai benda Allah ni. Times height. Okay, so my area of circle is pi r squared. My radius, I already converted it to meter. So 0.5 squared, pi r squared. Times with the height. The height is given as 2.5 meter. Okay, so this dude is in meter squared. And this is in meter. Okay, so now that I have this formula, I just use my calculator. So 0.5 squared times pi times with 2.5. So I got 1 point. Lain kejap. Pi r squared. Betul dah. Pi 0.5 times 2.5. This is meter, not meter squared. Excuse me. Okay, so I got 1.96. 2 decimal places, so 1.963, 1.96. Okay, so I got 1.96 meter. So what should be over here? So I have 2 here, and this is 1. So this should be 3 meter cube, because it's volume lah. Okay, so area times height, meter squared times meter gives me meter cube. Meter cube. Volume is in meter cube. Length times length times length. Okay, so now it wants me to tell them what is it in liters. So unit conversion, 1 liter is 10 to the power 3 centimeter cube. Tak kasi saya meter lah pula kan. Okay, tak apalah. Basically, if I use the same conversion, I will get this answer. Okay, so how do we do this one? Let's do it. Let's just do it. We're not rushing pun. Okay, let me pisahkan this one. Let's use a different color because I'm feeling it. Okay, so I have 1.96 meter cube, right? They've given me a conversion in this form. How do I do it? So 1.96 meter cube, right? So I want to convert it to centimeter cube. How do I do it? So I want to get rid of meter. How many centimeters is in 1 meter? It is 100 centimeter. Is this enough to cancel the meter? No, it's not enough. 100 centimeter over meter times 100. Tak cukup tempat pula. Kejap. Okay. So, okay, back to this thingy. 100 centimeter over meter. So now is it enough to cancel out all the meter? Yes. So cancel out 1, 2, 3. 3. So now I have 1.96 times 100 times 100 times 100 centimeter cube because 1, 2, 3. Okay, so I will get the answer as 1.96 times 10 to the power of 6 because I have like 6 zeros, 1, 2, 3, 4, 5, 6. 10 to the 6 centimeter cube. Okay, my job here is not done yet because mandai sangat nak buat in meter kan tadi. Okay, 1.96 times 10 to the 6 centimeter cube. How do I convert this to liter? I can continue my work over here but I don't have much space, so I'm just going to do it down here. So let's use a different color because why not? 1.96 times 10 to the 6 centimeter cube. So 1 liter is 10 to the 3 centimeter cube. How do I cancel out the centimeter cube? So times 1 liter over 10 to the 3 centimeter cube. Or you can just say this as 1000. Okay, but I think better to leave it as 10 to the 3 because we are working with scientific notations. So 10 to the 6 over here, 10 to the 3 down there. So when we have division, we just minus it. So 1.96 times 10 to the 3. The centimeter is cancelled out already. So I am left with liters. So is it the same as this guy? Let's see. 1, 2, 3. 196. Oops. 1960 liters. The end of our misery. Okay, so that was quite lengthy, but when you get used to it, you'll do it very fast. I purposely slowed down myself so that everyone could be on the same page. Any questions about this one? Nanti boleh buat laju-laju je ni patutnya, like 1 minute tops. So far, everyone okay? Still holding on? Not dying yet?
Okay.
Okay, another minute again. I think another 7 minutes to our break. 5 minutes, 5 minutes. Okay, a little bit more and then we will have our break. Okay, next one. Banyak example. Example 1.3. The weight of an object of mass m0 on a planet is given by the equation as such, where G is 6.67 times 10 to the minus 11 meter cube. Sorry, meter cube lah. Betul lah, meter cube. Meter cube per kilogram per second squared is known as the universal gravitational constant. You will learn this in chapter 5, don't worry. Okay, and MP and RP are respectively mass and radius of the planet. Just bear with me on this one, okay? What is the weight of an object? Weight of an object of mass 2 kilogram when it is on the moon, given the mass of moon as this guy and the radius as this. So just use the equation. G is given. Just plug it in. 6.67 times 10 to the minus 11. This guy is in meter cube over, whoops, second squared, okay, times 2. Where did the 2 come from? This is our m naught. M naught is given by the weight, the object of mass. The object of mass is 2 kilograms. So this is where we got the 2. So times with kilogram. Okay, this is not very clean. Let me besarkan. Since this is our first time doing this, I should be more careful. Okay, let me try again. Mana tadi? Meter cube over kilogram second squared. This is the first guy punya unit. Second guy punya unit mass, and then mass MP. What is MP? It's the mass of the moon or the mass of the planet. This guy. So 6. Kenapa dia letak nombor lain? Tak apalah. Kita akan go with this number. So 7.36. Where did it come from? 7.36 ni. Sorry saya tak perasan example ni melalut. So 7.36 times 10 to the 22 is the mass of something. You don't know if it's the moon. So this is in kilogram. Okay. And then we have RP. What is RP? RP is radius. It's the radius of whatever planet that is or the moon. We are not sure anymore. So this guy is in meter. It is squared, so it becomes meter squared. Okay. So now I use my calculator, blah, 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 calculate everything. I get 3.24. But I want to know if I really get Newton with this equation. Okay, so we are doing a little bit of dimensional analysis here. So the numbers, it's fine. The numbers is fine. Just use the calculator. But I want to know what is the unit that we get from this equation. So we have meter cube over kilogram per second squared. We have kilogram over here and we have kilogram over here. We have meter squared down here. So let's do our favorite thing. I mean, this is my favorite thing, which is canceling out stuff because it makes my life easier. Okay, let's use a red color. So meter squared down here, cancel out. I'm left with meter. So I have 1 kg here, cancel that out with this guy. So this kg is on top, this kg is down, so I can cancel them out. So I'm left with another kg here. I can't cancel it out. And I'm left with second squared. So my unit is meter, kilogram. I hope I'm right. Meter dot kilogram over second squared. Okay, so let's see if this is actually Newton. Meter, kilogram over second squared. Let's go back to our derived quantities. It's not it. I forgot which slide it was. Was it this one? Kilogram, meter over second squared. So let's see. Kilogram, meter over second squared. So this is the unit for weight or force. Weight is force. Weight is force, gravitational force lah basically. Let's go back to the example. Kilogram, meter over second squared. Yay, so it is Newton. So this is our weight. Okay, so why am I teaching you this? Why can't we just use Newton immediately? Yes, you can use Newton immediately, but sometimes you need to know the dimensional analysis so that you can double check on your calculation. So this is like easy example of checking that dimension. Sometimes it gets harder, so I'm just giving you the tools, okay, to get there. Okay, so moving on. Is it time for it? No, we have another 2 minutes. Okay, so moving on to the next stuff, which is type of quantities. We have scalar and vector quantities. What on earth are these? Scalar only has magnitude. Vector, he wants to be fancy, so he has magnitude and direction. So vector is the fancy guy. So scalar only has magnitude. For example, length. Length only has magnitude. If I tell you, okay, this ruler is 5 centimeter, pendeknya. This ruler is 15 centimeter. Do I know the direction of the ruler? No, I only know that the length is 15 centimeter. So a ruler has a length, oh buruk ni tulisan, has a length of 15 centimeter. Do I know the direction? No, because it's length. Length is not supposed to give me direction. So length is under scalar quantity or distance. Boleh Distance or length. And then speed, work, temperature, area, density is under scalar. If you talk about it, you won't know the direction. So I tell you, okay, my circle, why do I have a circle? I don't know. Okay, I have this tumbler. So I say, okay, this circle is, what's a logical value for that? Let's just go with it. It's like 10 centimeters squared. That's the area. So I tell you the area. So do you know what the direction of my circle is? No, because I'm just giving you the area. You won't know the direction. So that is why it's called scalar quantity. And also density is also does not have direction. Speed does not have direction. Okay. And then for vector quantities, when we talk about position, we have to know where exactly is the position. We will talk more on that. And then velocity. Velocity is basically the same as speed, but it has direction. Okay, so you use this, they can have the same value, but velocity has to have direction. Force has direction, magnetic field has direction. Okay, so what is the takeaway from this slide? Scalar only cares about magnitude, vector quantities care about magnitude and direction. Okay, so let's take our break for 5 minutes. Let's come back to this. So 5 minutes from now is 2:57. Let's come back. Okay, so if you guys have any questions, feel free to ask. Want to go to the toilet, get your snack, whatever, please do so in 5 minutes. I have one chat. Doktor, saya tak boleh submit sebab tak ada tarikh untuk hari ini. Okay. Nurin kejap. Okay, Nurin reached out to me, so I'm going to sign in for her. Izati dengan Rashidah ni macam mana? Stop sharing. Oh, sorry, saya yang terbabas. Okay, is everyone back? Everyone still okay?
Okay.
Hey.
Okay.
Yes, teacher.
Pertenang kan? I know you guys. Okay, I hope you are still with me. Saya tak tahu macam nak buat dah. I will try to be more entertaining. Okay, so let's continue. Let me delete this one first. So what have we learned so far? Let's just do a little recap really quickly. Okay, because we've talked about for like 1 hour. I talked for like 1 hour. You guys like kept quiet with no interaction. It's pretty boring for me, but that's okay. Semua orang tak warm up lagi. So what have we learned so far? We talked about base quantities, right? We talked about base quantities and we also talked about derived quantities. So can anyone tell me what is base quantities and what is derived quantities in their own words? Doesn't have to be accurate. It can be what is your impression of base quantity versus derived quantities? Anyone? No one wants to try? Come on, this is like the easiest question ever.
Can I try?
Yes. Sharifah.
Okay. So macam base quantity is like something that cannot be broken down to a smaller unit.
Okay,
For
betul.
example, length, time,
Okay,
and for
thank you.
derived quantity, you can break it down to more smaller units. For example, macam speed, it can be broken down to distance over time.
Okay, excellent. Thank you for that answer. Can be broken down, for example, speed is length over time. Okay, so you guys have to memorize what is the types of what are base quantities and what is derived quantities. And then we also talked about scientific notation. So my handwriting is a bit wobbly, don't know why. Scientific notation. Okay, basically if you have like a bunch of numbers, blah, blah, 6699, and you're like, okay, I don't want to remember this, you can change it to scientific notation. 1, 2, 3, 4, 5, 6, 7, 8. 9 times 6 to the 9 times to the 8 times 10 to the power of 8. And then we talked about, what else? We talked about, other than scientific notation, we can use prefix. Is it called prefix? Let's go back to the slide. It's called prefixes. Okay, so you have like giga, mega, kilo, all that stuff that you memorized in high school. So you can do that. So for example, you want to change this to mega is 6, giga is 9. So you want to change this, you can change this to giga. So 90, 0.969 giga or of something, right? Okay, so this is called prefix. Then you have scientific notation. And what else did we learn? We talked about the units, SI units, right? We talked about SI units, meter, kilogram, second, ampere, Kelvin, mole, candela. Okay, so I think it's pretty straightforward so far. Okay, now let's go to our next subtopic, which is vector quantities. So vector notation. So vector quantities is something that has magnitude and direction. So two things that a vector has to have. So to write a vector, you can either see it in this form. It's you can write it as A bold in your textbook. Contohnya dia cakap, macam nak cakap? Okay, Ali's. Let's not use Ali. What is so generic name? Let's use Anik. Okay, Anik. Sabar saya tak ingat lagi nama semua orang. Nanti saya akan pakai untuk semua slide saya. Don't worry. So Anik has a weight of, oh sorry, this is about berat. I hope I don't offend Anik. Has a weight of, dun, dun, dun. Everyone's like, what is Anik's weight? Wait, I don't know, 70 Newton. Oh, ringan gila. 70 Newton contoh. 70 Newton. So in the textbook, if they write it like this, Anik has a weight of 70 Newton, they will make this thing bolded. Okay? When they bold this unit, it means that it has direction. And does Anik's weight have direction? Yes, because Anik only weighs down because due to gravity, right? Takkan dia nak weigh ke atas pula kan? Nanti dia melayang-layang lah. So Anik's weight goes down because that is the gravitational force. So when they bold it, you know, oh, this 70 has a direction and the unit is in Newton. Okay, so that is one example in the textbook. And the most common one is using an arrow on top. Okay, so use an arrow on top. Let's see, ada tak example yang ada arrow tu? Let's see. Okay, so it's saying vector A. I immediately know that A is a vector because it has this arrow on top. I immediately know it's a vector. If I just write it like this, A, meh, it's not a vector, right? But if I put a arrow on top, I can write it half arrow or like a full arrow. Boleh dua-dua. So I have this arrow. Okay, oh, I immediately know when I look at it, I know this is a vector. Or if I have an A that is bolded, tiba-tiba, macam tiba-tiba randomly bolded. Okay, this is a vector. No doubt about it. Okay, so these are the two ways you can identify a vector. Okay, so a vector quantity can be represented by an arrow drawn to scale in the appropriate direction. Okay, doesn't tell us much. Move on. A vector of magnitude 1 unit in a specific direction. Okay, so let's take a look at this example. So I have this arrow. This arrow is representing vector A. This arrow represents vector A. And I have this like unit called small a. Small a is to the right and the length is this much. So this small a is a vector. It is to the right and the length is 1 unit. Contoh. So vector small a is to the right and has a length of 1 unit. I'm just defining it randomly. Yeah? To the right and length 1 unit. Yang unit ni saya cakap je lah. To the right ni obviously it's going to the right. Okay, so I want to define vector capital A in terms of small a. So I can see that, okay, so if I want to define capital A in terms of small a, I can see that the small a, I need to have two small a's to make the capital A. So I can define vector A, capital A, is equal to 2 small a vector. Okay, so that is it. So why is it possible to define it like this? Because capital A with small a has the same direction. So that's why I can define it like this. If my small a is not in the same direction, for example, my a is defined like this. My small a is like this. The length might be the same. Anggaplah sama dia punya length. The length might be 2 units, but the direction is not the same. So I cannot say capital A is equal to 2 small a. Capital A is equal to small a because the direction is not the same. So for a vector to be equal, they need to be the same in magnitude and also the same in direction. Okay, I'm going to repeat myself. For a vector to be the same, they have to have the same magnitude and the same direction. If they don't have the same magnitude but they have the same direction, they can be defined but ada nombor lah, ada scale. So capital A is equal to 2 small a vector, like that. But if my small a is in a different direction, this is not possible to define at all. Okay? So let's take a look at another example. We have this one vector. It's called small r. I immediately know it's a vector. It has a magnitude and it has direction. So small r is 1 unit in length and its direction is this direction lah, okay? And I have this big vector called r, capital R vector. I want to define capital R vector in terms of small r vector. So I can see that, okay, to satisfy, to have the same length, I need to have four small r's, right? So 4r, 4 times r is the magnitude. The direction is the same, so this is correct. Okay, so again, what is the takeaway from this? For you to define one vector in terms of the other, they have to have the same direction. The magnitude can be different, but nanti tambahlah dia punya magnitude tu kemudian. That is just like multiplication of the length. So that's fine, as long as it's in the same direction. If it's not in the same direction, you can't define it in terms of the other vector. Okay. Equality of two vectors, like I mentioned before, for two vectors to be equal, they have to have the same magnitude and also the same direction. Okay, for example, vector A is equal to vector B. I can write it like this. Is vector A equal to vector C? They have the same magnitude, but the direction is not the same. So this vector is not equal, even though they have the same length. Okay, so vector C is not equal to vector A. And of course, it's not equal to vector B as well. Okay, so we have negative vectors as well. So that we just talked about vectors that are in the same direction or totally lain. What about if they are parallel, but they are not in the same direction. Parallel maksudnya selari lah, selari. But vector A is pointing this way, vector C is pointing this way. Can I define vector A in terms of vector C? I can, but it will have a negative sign like this. C vector is equal to minus A vector. Boleh, but dia parallel. Okay, but kena ada negatif lah. So you know that they are opposite in direction. So the negative sign tells you they are opposite in direction. Okay. Okay, so now we move on to addition of vectors. What have we talked so far about vectors? We talked about vector notation, kena bold ataupun ada that arrow on top of the what do you call it? Symbol. And then we talked about unit vector, defining one vector in the other. Okay. And then we talked about equality of two vectors. And then we talked about if they are parallel, but they are in the opposite direction, one of them will have a negative sign. Okay, so now we talk about addition of vectors. Okay, addition. So you can add or subtract vector quantities of the same kind. Maksud same kind kat sini is the same direction. Oh, sorry, not like that. Add and subtract vector quantities of the same kind. Maksud kat sini, please scratch what I said just now. Same kind here meaning vector like Newton plus Newton. You can't add Newton with speed, right? Sorry, speed is scalar. Velocity. Let me be clear with this one. Add and subtract vector quantities. So vector quantities that I want to add, for example, weight is a vector quantity plus with velocity. It is also a vector quantity. Can I do that? Weight is in Newton and velocity is in meter per second. So they don't have the same unit, so I cannot add them together, even though they are both vectors, but they are not of the same kind. So if I wanted to add weight with weight, I can do that, even though they are different direction, I can. Okay, so or weight with friction. Friction is also in Newton. So I can do that. As long as they have the same units, you can add them together. But there is a technique to adding vectors, which we will learn in a bit. Okay, so point number one, please add of the same kind, Newton with Newton, meter per second with meter per second, stuff like that. And then you can, okay, I think I made my point here. So how do we add vectors? Okay, so if I have one vector R1, I want to use orange. I have one vector called R1 over here. I know it's a vector because there's an arrow. Please look at this arrow. It's a vector. Bila terang-terang cakap, hello, look at me, I'm a vector. So R1 is a vector and R2 is also a vector. R1 is to the right, R2 is to the right. So this is pretty straightforward. So R1 vector plus R2 vector will give me something called resultant vector. Resultant vector. And most of the time, it will be denoted as capital R with that arrow thingy on top. That is your resultant vector. The resultant vector of R1 plus R2 vector is this guy, R vector, resulting. So R1 plus R2 gives me resultant vector of that guy lah, that arrow, that orange arrow. Okay, so this is straightforward. R1 and R2 have the same direction, easy peasy. So what if two vectors have different directions? So this is where we have to apply special skills. Okay, so please pay attention. So I want to add vector A with vector B, right? So there are several ways to do it. Let's see. Vector additions obey the commutative law of addition. The order in which the vectors are added doesn't affect the result. For example, vector A, this guy is bolded, you know it's a vector. A plus B is the same as B plus A. It doesn't matter the order. So if I have more than two vectors, A plus B plus C, it is the same as C plus A plus B. So I don't care about the order. As long as the vectors are in addition, it should give me the same answer lah. Don't care about the order. Okay, why is this important? Because this is where we learn about the technique. Next, we have several techniques of addition of vectors. The first one is called geometric method. Geometric method, you can add them tip to tail or tail to tail. Okay, and you're asking me, oh, benda ni, tip to tail, kan? Okay, so remember I told you a vector can be defined using an arrow. So I have a vector A. Why is this like so small? Vector A, my vector is this guy, A, contoh, yeah? Contoh A, vector is this guy over here. And I have another vector called B. Oh, besar gila. Okay, never mind. It's okay. Oh, besar sangat. Let's rewrite that. Okay. So this is my vector B. Vector B. Okay, so A plus B. I want to try the tip to tail method. Tip to tail. Tip to tail. What is tip? What is tail? Okay. So I want to use a different color as usual. So this is my tip. Tip ni hujung yang kat depan. Okay. And tail ekor kan? Tail. This is my tail. Okay, what about this guy? This is the tip. This is the tail. Okay, fine. We know our arrow has a tip and a tail. So what is the tip to tail method? So I want to add A vector plus B, right? So I want to use tip to tail. So this is tip to tail. Maksudnya, I start with my A vector. My A vector is like that. I try to make it similar. This is my first vector, B. I want to add it with B. So tip of A to tail of B. This is the tail of B. So it goes this way. This is the tip of A. This is the tail of B. Tip, tip to tail. A plus B. Okay. And then you're asking me, okay, kita dah letak tip to tail. How do I get the resultant vector? So A plus B is going to give me something called a resultant vector. So resultant vector goes from your initial point. Your initial point, I'm using like a lot of x's and your initial point, let's rewrite. Oh no, no, come back. Okay, it's back. Where is your initial point? You started from here, A, and then tip to tail, B. You started, this is your initial point, right? This is where you started. At 0 second, this is where you started, okay? So from initial point, and this is where you ended, to the end point, from the initial point to the end point is your resultant vector. The direction of arrow is from the initial point to the end point. Okay, now my A is like menyibuk kat situ kan. Okay, let me rewrite the A over here. This is my A vector. I start from here. I write A. I draw A. This is my A vector. Tip to tail. So this is my tip. I connect it with the tail of vector B. This is vector B. So B. Okay, so this is where I end. A plus B, right? This is where I started. This is where I end. I want to find the resultant vector. How do I do it? I go from the initial point to the end point. This is my arrow. My resultant vector is going down like that. The arrow is going down. Okay, so that is how you use the tip to tail method. Let's use a different example yang teratur sikit. Okay, for example, this guy. We have A vector and B vector. I want to find what is A vector plus B vector, right? It doesn't matter if I start with B or if I start with A, jawapan dia akan tetap sama. Okay, but in this case, we start with A. So A, this is the tip of my A. This is my initial point. Okay, initial point where I started this whole thing, right? Initial point. So I start, I start from here. I end my A vector over here. This is the tip of my A. I connect it with the tail of B vector. So this is my B vector. This is where I end. Okay, at this point, I don't know what the resultant vector is. Okay, so how do I know where the resultant vector is? I draw my line from the initial point to the end. I go like this, and this is my arrow direction. This is called the resultant vector. Or sometimes you can write it like this, A plus B vector. Boleh juga. But preferably use the resultant vector. Okay, so this is how you use the tip to tail drawing. Okay, saya dah buat slow dah supaya everyone understands. Okay, so what if they tell you, okay, vector A is like 100 meter. Vector B is like 50 meter. How do you draw that on paper, right? It's not possible. Your paper is like A4 je kot. So how do you do that? So you choose a scale. This is what they mean by choose a scale. So you want to define, let's say, 10 meter is equal to 1 centimeter on paper. So if I want to draw vector A, which is 100 meter, that will become 10 centimeter on paper. Okay, so I have to precisely draw this as 10 centimeter on paper. Walaupun A dia cakap 100 meter, but my paper tak fit 100 meter, so I'm using a scale. Okay, so A vector on my paper, I draw it using a ruler and a pencil, and the length is 10 centimeter. Why is it important to be precise? Because you are going to find out what is the length of your resultant vector using your paper. Okay, on paper. And then vector B is 50 meter, it's given. Okay, so we have to convert that. Vector B is 50 meter. How much is that on paper? It's 5 centimeter on paper. So this will be 5 centimeter. Draw it exactly precisely using your ruler and your pencil. Tip to tail, 10 centimeter. Tip to tail, 5 centimeter. And then from your initial point to the end, on your paper, you measure it. You measure using your ruler and you find out that it is 17. Contoh, saya tak tahu jawapan dia apa. Contohnya jawapan dia 17 on paper. So what is the actual value of your resultant vector? So you have to convert back. So if you said 10 meter is equal to 1 centimeter earlier, so 10 centimeter is actually 170 meter. So vector R is 170 meter. What about the direction? You have to measure the direction of theta using your protractor. Okay, pakai protractor. So this is why virtual is like little bit hard sebab susah nak tunjuk benda-benda ni. But that's okay. We try to make do what we can. So resultant vector, the magnitude is 170 meter. How did I know? Because I measured from here to here, it's 17 centimeter. So I convert it back using my scale. Okay, this is the scale. So it is 170 meter. What about the direction? I measure it from the x-axis. So the angle of R with respect to the x-axis, that is the direction. Contohlah, jawapan dia 45 degrees. Okay, so I will answer in the test. The resultant vector is 170 meter and 45 degrees. If you write 45 degrees, it is understood that it is with respect to the x-axis. Or if you want to be safe, with respect to the x-axis. Okay, is everyone okay so far about the tip to tail thingy?
Yes.
Any questions? Okay, no question, eh? Okay.
Doktor.
Yep.
Waktu kita nak lukis vektor A dengan vektor B tu kan, apa sudut antara tu dia tak bagi ke?
Oh, dia bagi. Dia bagi. So basically dia akan bagi either arrow tu siap-siap direction ataupun dia bagi tahu A is 100 meter and direction of kat sini 0 lah. 0 degrees with respect to x-axis. Okay, so this is your A vector. Boleh, diorang boleh cakap macam tu. Or they can give you an arrow diagram. And then they can say for B, B is 50 meter and has a direction of looks like 75 degrees with respect to x-axis. So when they give you a statement like this, you have to draw it yourself lah. Okay. So when they give you angle, it's always with respect to the positive x-axis. Okay, always. Okay. Any other questions? Good question. Good catch. So everyone's okay? Okay.
Doing good.
Okay.
All right. Good.
Okay.
Okay, so that we talked about two vectors just now. What if we have more than two vectors? We can still use the same method, tip to tail drawing. So in this case, this is A vector plus B vector plus C vector plus D vector. Okay, and this is the resultant vector. Resultant vector. Resultant vector is the addition of A vector, B vector, C vector, and D vector. So they can give you A vector is let's say it's 90 meter with 0 degrees angle. Okay, and then B, and then they define all the vectors. So just use that method to tip to tail. So let's go through it. So I first draw my A vector using the statement that they've given me. A is 90 degrees, sorry, 90 meter with 0 degrees. So 90 meter. I convert this to a scale that I'm comfortable to draw on my paper. Let's say 10 meter is 1 centimeter. Boleh? So I will draw. Okay, this is my scale. Okay, so everyone has to follow this scale. I mean, all the vectors, not everyone in class. So it depends on you. If you want to define 10 meter as 2 centimeter, boleh, tak kisah. Asalkan consistent. You use the same scale for all the vectors that you are drawing. As long as you are consistent, it will get you the right answer. Okay, so I say A is 90 meter with 0 degrees. This is my scale, 10 meter is 1 centimeter. So this guy over here, I draw it on paper. It should be 9 centimeter. The angle is 0 degrees with respect to the x-axis. Basically, it's on the x-axis. Because kosong degrees. And then B is like 7 centimeter. I'm just making this up. And this is 20 degrees. We can say B vector is 70 meter with 20 degrees with respect to the x-axis. And C is something more than 90. So let's say it's 100 degrees with respect to the positive x-axis. This guy is 8, and this guy looks like it's longer than this guy, but smaller than this. Oh, I caught myself. So this guy should be 8.5, maybe, I don't know. 8.5 meter, and the angle is something that is more than 90 degrees. 135, maybe. Okay, so draw it precisely using your ruler, using your protractor, use the angle. I mean, you have to draw the angle precisely to gut, because if not, you will get the wrong resulting when you draw the tip to tail. So tip to tail, tip to tail, tip to tail, and then this is where you end. This is where you started. So this is, you go from the start to the end. This is your resulting. Start to the end, that's your resulting. Always from the start to the end. Okay, tulisan buruk tapi sila faham. Okay, resultant vector, always you draw it from the start to the end. Okay, so that's one method. We have other methods. Okay, so another one is called the tail to tail drawing. It's almost the same, tapi kita connect all the tails together. So in this case, A vector plus B vector, I want to use the tail to tail drawing. So I first draw my A vector. Where's my tail? It's over here. And then my B vector is connected to my A vector tail. So the tails are like connected together. And then the next step is to draw a line that is parallel to vector A. Draw a line that is parallel to vector B. We do it in dash. Sebab dia bukan vector. You're just like, macam nak cakap, trying to meet these 2 points together. So it's not a vector. I'm just making something that is parallel to vector A, something that is parallel to vector B. I connect these two together. Okay, this is the end point of my resulting. I shouldn't say end point. This is the tip of my resulting. of R. This is the tail because everyone is connected by the tail. So this is my tail of the resultant. This is the tip of my resulting. And I should draw write nicely. Tip of R. Tail of everyone. Okay, this is why it's called tail to tail. All the tails are together. Tak kisahlah nak tambah. Oh, sorry. For tail to tail, you can only add 2 vectors at a time. If I'm correct. I think so. Sekejap. 1, 2. Yeah, you can only add 2 vectors for tail to tail drawing. For tip to tail, you can add a bunch. Okay. Sama juga, use the scale that you are comfortable with. Draw it on paper precisely using your protractor and your ruler. Sama je. Only that is tail to tail. And then this is your tail of your resultant. This is the tip of your resultant. Whatever the length that you get, convert it back using your scale. That is your magnitude of your resultant. What about the direction? Direction is always with respect to the x-axis. So this is the theta of your resultant. Okay, so this is, let's say, is 30 degrees. And this is 170 meter. I already changed it to the scale. So my answer is resultant vector. The resultant vector is 170 meter with 30 degrees with the direction, and the direction is 30 degrees with respect to the x-axis. Okay, again, it's the same, except that you have to connect all the tails together. Even your resultant punya tail stuck there. Okay, it's stuck. Okay, so that was the first method was tip to tail. Second method was tail to tail. Tail to tail, only 2 vectors can be added together. Tip to tail, you can add a bunch of vectors. Okay. Okay, so this is the third method. It's called the algebraic method. Most of the time we won't use this. Yang famous is the tail to tail and tip to tail. I believe you covered this in high school, but that's okay. Let's just go over it really quickly. So I want to add, this is supposed to be a vector. Let's try it like this. I want to add A vector with B vector. So A vector plus B vector gives me C vector. This is also a vector. So C vector is R vector lah in this case. Boleh R vector, you can change the name, but R vector is like universal. When people look at R, they know, oh, this is the resultant. But it's not necessary for you to name your resultant as R. You can write it as D, C, whatever that you like. Okay, so in this case, the resultant vector is called C. Okay, so using your what do you call this, triangle rule. But first, to use this triangle rule, you have to define all the angles associated with this triangle. All the angles associated with this triangle. Betul lah tu. First, you draw the A tip to tail method. Sama je, tip to tail. And then you connect the resultant. But you don't want to use your ruler. You don't want to use your ruler. You don't want to use your protractor. This is where the triangle rule comes in handy. I do not want to use ruler and protractor. So I want to use math. Okay, this is where the triangle rule helps. Okay, so draw the tip to tail like usual, and then the C. But in the question, they should already have defined all the angles. So you just use this equation. So C squared, this is the vector length, vector length, vector length, vector length, vector length. This is the angle over here. The question should already define it. If not, you have to find it before you can use this equation. Okay, I think it's quite straightforward. If C is like 10, sorry, you don't know the answer yet. So B is like 5, that's the length of the vector, and A is like 3. And they told you the angle over here is something 30 degrees, and this is like 20. So a triangle has 180 degrees, so this gives me 130. Okay, so I know that C is 130. So C squared is, I don't know yet, A squared is 3 squared plus 5 squared minus 2, 3, 5 cosine of 130 degrees. So you will get C squared over here, and you want to find C, right? So you square root this whole thing, you will get the length of C. So this is how you use the triangle rule. Okay, so you know what is, oh sorry, patutnya cari angle pakai ni dulu. But it's okay, I think you guys get it. So A is 3, and over here they given you sine of 20 degrees. Okay. So this is sine of 20 degrees. They gave you capital A and capital B punya degrees, and then B is 5, right? Sine, what is B? 30. Okay, so now you found what is C. C is 10 maybe. So C is 10. You want to know what is C. Contoh lah, kita tak tahu lagi waktu ni. So I want to know what is C. I have the angle of B, I have the angle of A, I have the length of A, length of B, length of C. So use this law of sines to find out the angle. Boleh. Okay, this is just like a recap. I'm pretty sure you won't have to use this in your exam because soalan ni memang dah orang dah jemu lah basically. This is new, right? This is new and this is new. So this is most likely what's going to come out. Okay, so I think you know this already. It's just a matter of revising the equations and knowing how to plug in the values. So I think it's pretty straightforward. Okay, so moving on. Subtraction of vectors. What time is it? I am tired. Let me have a break. Jangan. Any questions so far? No questions? Everyone's
No.
okay?
No question.
No question. Okay, thank you. Special case of vector addition. Okay, so we have two vectors here, vector A and vector B. We talked about the addition of vector, tip to tail, and we can also use law of triangle. What if they want you to subtract vectors? So A minus with B vector. I have these two vectors. What do? I just flip it. Flip B the other way round. So this becomes minus B vector. So using the same method, tip to tail or tail to tail. In this case, we are using tip to tail. This is A vector, tip, and then tail of B vector. I'm adding the minus B, tip to tail method. This is tip to tail, but in this case, I'm adding A vector minus B vector. Okay, so A plus minus B vector. This is where you start, and this is where you end. So let's draw the resultant vector. It should start from here and end over here. This is my resultant vector. Sama je. But you need to know the direction of your vector lah. If it's a negative, terbalikkan dia. Okay. Okay, so resolving components. Okay, so because I'm tired, let's watch some animation. Stop sharing. Share screen. Where is my Google? It's here. Where is it? Okay, it's here. Okay, so let's go for some animation because I'm tired. Let's explore this 2D equation. Oh, tidak sampai equation lagi. Let's explore 2D first. Okay, can everyone see my screen?
Yes.
Melepit. Second day of school, second day of uni, pra-uni. Okay. So I have two vectors that I want to add. Typical situation that we impose on ourselves untuk menyusahkan diri kita. Tapi tak apa, kita nak belajar. So I have a vector over here, and I want to add another vector, vector B. Let's make it a little bit rough. Kat sini lah. Nampak macam pelik sikit kan? Okay, so I want to find out, hey, where is my resultant vector? So tip to tail method, I'm going for the tip to tail. So this is where I started. This is where this is the tip of my A vector. And then this is the tail of my B vector, tip to tail. Okay, and then this is where I end. Okay, so now I am trying to find the C vector. Hello, why are you like this? Oh, ni kot. Sekejap, let's see. Is it this one? No. So C that, oh no, it's not that. So I want to find the sum of these two guys. So the sum is given by this S vector. Dia tak panggil R, dia panggil S, sum. So this is my resultant vector called S vector. So A plus B gives me S vector. So now I want to know, hey, what's the length of S? The length of S is 28.6. The length of A vector is 20. Let's see. This is 0, 5, 10. So this is 5, 5, 10, 15, 20. So yes, vector A is 20. This is if you're using a graph paper. Macam samalah. Sekejap besarkan sikit. Tak boleh besarkan ke? Oh my god. Why? Tak boleh besarkan? Okay, tak boleh. Sekejap, let me try another method. Oh, tak boleh. Jahatnya. Okay, so tak apa. B vector is 10, 10, the units is 10. That's the length. Okay, and then using the graph paper, I find out that it is 28.6. Pandailah korang pakai scale yang sesuai. And then I want to know what is the angle of my resultant vector. Oh, ni buang grid. Tapi saya tak nampak. How do I make it? Okay, so I click on this vector S, the unit dalam modulus ni. S vector modulus gives me the length. Okay, gives me the length. Then the theta is the angle with respect to the x-axis. The angle is 12.1. And then, okay, this is where I want to introduce you to something new. This is SX 28, SY 6. What is that? So I have this vector. I have this S vector, and it's telling me the x component of S vector is 28 in length, and the y component of vector S is 6. So what does this mean, right? So is there any other buttons to help me with that? Okay, so if I want to like demonstrate what is the S, X, and Y components of S vector, let me repeat myself. I want to demonstrate the X and the Y components of the S vector or the resultant vector. It is like that. Yeah, this one 6. The Y component of S vector is 6. The X component of S vector is 28. Why do we have this? Okay, so basically all vectors have this. Okay, surprise. So all vectors have this. So I did not tunjuk lagi sebab I wanted to introduce the addition and subtraction, blah, blah, blah. So, but the most important thing in this chapter is actually the components. The components. Okay, let's do a different example. So I have a vector C lah. let's use a different A. Okay, refresh. Let's use a different example. Okay, so what if I just want to talk about one vector? I don't want to know the resultant vector yet. Does it have a component? Let's see. So my A vector is this way lah. Okay, bagi dia macam pelik sikit. So this is my A vector. It's a single vector. I'm not adding it with anything. It exists on its own. It exists on its own. So does it have components? The answer is yes. If you look here, because I'm selecting this vector, it has an X component of 17 and it has a Y component of minus 11. Tadi semua positif. Tadi kita punya S vector, the value of the X and the value of the Y was positive. Now we have something, this A vector, we have the X component as positive, the Y component as negative. Why? Let's see. So I'm going to click on this and it gives me the X component over here and the Y component over here. So the Y component is going down. Typically, we say that going up is positive. So if it's going down, it should have a negative sign. This is a vector. And it's going to the right. Typically, when we go to the right, we are saying that it is a positive. So it is going to the right. The value is positive. So all vectors have these X and Y components. And it's very important to understand this. Okay, so let's go back to our slide. What time is it? Okay, let's go for another 5 minutes and then let's end class. We are at 3:50. I know everyone's like dying inside lah. Lama lagi ke nak kelas ni? Sikit lagi 5 minutes to go. Stop sharing. Let me share again this slide. Okay, let me talk a little bit more on the X and Y component first before we start with the merepek-repek ni. Okay, basic. Let's talk something basic first. Very important for you to understand this. I see my students sometimes struggle kat SEM2 sebab dia tak tahu vector components macam mana. So it's very important to understand this concept. Okay, bear with me, 5 minutes, I promise. So I have one vector A like this. Okay, my A looks like weird, but that's okay. And then I have B vector like this. I have C vector like this. And I have another one over here like this, D. Okay, so I want to know what is the X and Y components of my vector. I don't want to know the value. I don't want to know angle of the A vector apa. I just want to know how to draw the X and Y components of my vector. Okay, so A vector, the X component is this way and the Y component is this way. Okay, so how do I draw it? I have my vector has to be in between the X and Y component. Dia kena tengah-tengah, dia kena tersepit kat tengah ni. It has to be in the middle. I am always in the middle. Okay, I am always in the middle. Okay, so if what about this B vector? I want to know what is the X component and what is the Y component. So my vector always has to be in the middle, but does it have a Y component? It only has an X component. So B is basically BX. It does not have a Y component. It's not going up, it's not going down. It only has an X component. Very important. Okay, what about C? Can anyone guess? How should I write the X and Y components?
Only have Y components.
I have component.
It only has one component, which is
Negative BY.
negative Y.
Negative
Correct.
CY.
So this is equal to just CY. It does not have an X component. And then for D, can anyone tell me how should I draw the X and Y component? For this guy over here.
Positive X component.
Positive X
And
component.
then negative X component and
Both of them are
positive Y
negative.
component.
Positive Y component.
Positive Y component. Correct. Okay, I think everyone's getting it. So your vector always has to be in the middle, and the components Kena sandwich lah the vector. So if I were to write this in an equation form, so this guy is cy plus cx equals to c vector. Boleh, I can write it like this. But since my cx is nothing, this becomes 0. So cy is equal to c vector. And if I want to write over here, ay plus ax is equal to a vector. Sorry. A vector. Is ay and ax a vector or not? Or is it a scalar? Is ay and ax a scalar or a vector?
Vector.
Vector.
Why is it a vector?
The direction.
There's a direction.
I can actually write it like this. Boleh. Yeah? So ay vector plus ax vector gives me a vector. So a vector ni macam resultant. Macam tail to tail resultant. Kalau nampak lah. Some people don't see this. So let's say this is A and this is B. This is my R. But in this case, this is AY, this is AX, and this is A vector. Sama je. It's just pecahan kepada components. But everything is vectors. So it's the same. And then for D, because we have a negative dx, right? So dy plus, so dx plus dy, I write it like this, equals to d vector. Okay, but when I put in the values, contohnya 10, because dx is going to the left, so this would be a negative 10x. And this would be positive 5y equals to d vector. Okay, so but if I'm writing it in general, I can write it without the sign, without the minus sign. Faham tak? Sebab saya tak bubuh value lagi. Tak apa, nanti kita akan go over more on this in next class. I hope everyone is okay so far. This will be available in recording if you want to revise. Okay. So other than that, have a great rest of the day. If you have any questions, you can ask them right now. Okay. No questions? Everyone's like tired. Okay, nothing from me. Have a great rest of the day. Yeah.
Kenapa C tidak negatif?
Kenapa?
C tadi.
Kenapa
C
C tadi?
tak ada negatif.
Oh, ada, sorry. C tu ada negatif. Sekejap, let me show back the class. Saya tak present lagi. Okay, so betul. It's going down, so it should be a minus lah, minus CY. So it's a minus CY. Betul. Okay. So nanti next class, we will talk more on these components and how to add these components. Okay. So that's it. Any other questions? Everyone's okay? What with what we've learned so far? Okay, I'll see you on Thursday. Bye-bye.
Bye. Thank you, Doctor.
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 Welcome. Hmm.
Thank you, Doctor.
You're welcome. Bye, Ikri. Let me see.